Okay, so the Sequoia Project is a nonprofit health tech firm that is dedicated exclusively to solving interoperability impediments. And we manage three major initiatives. The first is the eHealth Exchange. That's the network for which I have responsibility. And we have about 75% of the U.S. hospitals, about 70,000 medical groups, and thousands of other providers who all exchange over 200 million clinical documents over our network every year. We also have or manage Care Equality. And Care Equality is not a health information network. It's the framework by which providers can branch out of their home network, like the eHealth Exchange, and exchange clinical information with other networks such as Epic Care Everywhere, Athena, eClinicalWorks, Commonwealth, etc., SureScripts, etc. And then we manage Pulse. Pulse is an application, a solution that was developed by CMS and Audacious Inquiry, and then turned over to the Sequoia Project recently to mature, roll out, and grow. And it's used by credentialed, volunteered clinicians in times of emergencies to help them as they treat patients. So the Sequoia Project created this national provider directory using the Argonaut FHIR specifications, and then we extended it so that it could also be used by our Pulse application, by our eHealth Exchange network, and then by the Care Equality framework. So when I talk about a provider directory, I'm not talking about an old school user interface that maybe showed patients or consumers which docs they could visit within their network. Instead, this is a FHIR-based directory that's used behind the scenes and called by various applications to connect the various healthcare facilities and providers across the U.S. The FHIR directory is used in production, and again, as I mentioned before, it's used by the eHealth Exchange network, those 75% of U.S. hospitals, by the Care Equality health information networks, and by Pulse. And you can kind of imagine, or let me help you imagine how Pulse is actively used. So Pulse was deployed, has been deployed twice, both times for California wildfires. It's still being rolled out. We're about to roll it out beyond California to some additional states. And the concept here is that you've got a patient who's been displaced, let's say, by a hurricane. And they don't know what their medications are, their problems are, their allergies are. They try to call their provider office back home. It's been flooded or is closed for other reasons. They try to call their pharmacy, same deal. And so they wind up in an alternative care setting. So they're in a church, or they're in a school gymnasium, or they're in a tent. And credentialed volunteer clinicians arrive. They use the Pulse application, which leverages the FHIR directory, and they use that to pull medical history so that they can more safely and effectively treat the patients. So, if you were to imagine an even bigger scale disaster, you might think of an earthquake. And so let's pretend for a moment that unfortunately a magnitude 7 earthquake strikes the Hayward Fault in California. And you can imagine this is big, and people are going to be moving from wherever they are to another location until the disaster is improved. In this case, the disaster hits 52 miles in the San Francisco Bay Area, and 7 million people are impacted. This shock impacts 77,000 households, and 800 people die. There are 18,000 in this scenario non-fatal injuries. 2,500 people are rescued from collapsed buildings. And we've actually got 22,000 people in this scenario who are stuck in elevators. And as a result of all this, you can imagine that you've got landslides, fires, aftershocks, and you're impacting 150,000 households and 400,000 people. So it is not a good situation. So this is where the Pulse network is activated to deal with the emergency, and it's activated typically by state emergency officials. And right after the earthquake, the first 72 hours are detrimental. So the damage is assessed. They look at the impact, and the volunteer clinicians show up. They log into the Pulse system. It confirms that they are credentialed to do their work, and be they in a tent or a church or a school or somewhere else, they're able to begin pulling patient histories so they can safely treat patients. So I'm going to turn it over to Eric Heflin. Hopefully I left him a little bit of time.
Plenty. Thank you. Thank you, Jay. So just to pick up on that, so that scenario Jay was walking through is actually not a Sequoia scenario. It was actually from the U.S. Geological Service, and the metrics and so on were from their simulation of an actual potential event. And Pulse actually, as Jay said earlier in the presentation, it's not really a network. Pulse is an application that ties into something like the Health Exchange Network, the Care Quality Governance Framework, including all of its members like Commonwealth and Care Everywhere and Athena, and eClinicalWorks and so on, and all their individual respective networks. So Pulse, just a quick kind of a alert for techies in the audience. And for the non-techies, we'll actually only have one technical slide here to show you. But for the techies in the audience, like myself, actually, by show of hands, how many people can say they're actually FHIR technologists as opposed to, say, business folks? Or yeah, okay, for you five, here's actually here's actually how Pulse works behind the scenes a little bit. So this is actually, Pulse was developed under the Argonaut work group that we had an honor of being part of. And this is actually a resource you may not have seen up to now. This is an organization resource. It's a FHIR resource. And this conveys information about some type of an organization involved within healthcare. It does not necessarily have to be a hospital. It could be an insurance organization. It could be others as well, too. So in this case, some of the key things in this structure is that we also have the name of the organization. We have data about it, such as when this organization was updated. We have the name, and right there is one value I fought for myself. Alias. Originally in the FHIR spec, alias was a field that actually only had one value. It was optional. That was it. But the problem we're trying to do is we're trying to solve the real-world problem of what happens when a patient comes to you and says, I was treated at that hospital over there. It's got the word deaconess in the name. Well, Beth Israel Deaconess Hospital has been known over time, I believe, by 13 different names through mergers, acquisitions, rebranding, and so on. So if a patient comes to you and they know it as Deaconess, maybe that was their name 5 years ago, you still have to find it, right? So the alias field here is actually, that's not a technical thing, that's a business thing. But that lets the patient present and say, here's the name of the facility as I know it, and as long as that was something to do with the legal name at one point, they have a chance of finding it. That's actually one of our contributions to the spec. It also has address information. One of our enhancements we've made is GeoIP encoding, and so you can actually search for Pulse or using Pulse or our healthcare directory that Sequoia has published, and you can search for, say, for example, give an address or a zip code, search for all facilities within 5 miles or 10, 30, 50, 100 miles of that localization. So we did that by taking the address and adding a latitude and longitude for here as well. We have contact information, and then the last field here is probably the most important, and that really is a pointer to its own resource called an endpoint resource. And that basically contains all the technical data to connect Pulse to the rest of the world. All right, so that's it as far as kind of the more technical aspects of this. Let me bring up a browser, and let's see what we can actually do live here. Okay, very good. So this is Pulse application, as are others. This is mobile responsive. So if we take and resize this to simulate smaller devices or larger devices, we can do so. Here, simulating an iPhone. It also could be a Galaxy. It could be an iPad. It could also be something else, like a truly responsive design that essentially resizes dynamically, based on the actual screen width. So for now, I'm going to go ahead and change it to, let's say, an iPad Pro. Give us a little real estate here. So we'll log into Pulse. The first thing that's presented is a response or a request for the credentials. And the way Pulse is designed is each state is a little different. They have typically a registered database of registered, pre-registered, identity-proof, licensed, credentialed, volunteer disaster response healthcare providers. And that database is different from state to state. So one thing Pulse does, it actually has the ability to tie in to an existing state database of pre-registered disaster response volunteers, or it actually can add them on the fly as well too, or it can import lists if necessary as well. In California, where this is deployed initially, this actually ties into the database live in real time. Okay, after I authenticate, we see a screen that actually you may not have seen before. I'm going to change the resolution here, see if we can make this a little more visible on the screen here. Just notice it's pretty small. There you go. Hopefully that's a little bit better. Let me try to make it even a little bit bigger. There you go. Hopefully that's a little more readable for those in the audience. One of the interesting concepts about healthcare in disaster response scenario is that the treatment occurs outside of normal facilities in many cases. So the first thing one has to do is, besides authenticating, is you have to say where you're located. Are you in a tent, on a university campus, and so on. So you specify typically what county you're located in. In this case, I'll choose Alameda County. And then you have another drop-down indicating, are you, for example, in a university stadium? Are you in a fairgrounds? Are you in a church? Are you in, a stadium or some other facility? So basically, you specify what's called an ACF or alternate care facility. By the way, the little icon here, this is simulating a touch device, and so the icon is simulating the finger, just in case you're wondering why it's not a normal cursor. Now we see the normal Pulse interface for allowing us to search for a patient. On the right-hand side, we see a patient list. We actually have information here. If we click on that, we'll actually see something directly relevant to FHIR. This list of locations actually occurs from a live pull in real time from the FHIR-based healthcare directory. And by the way, I'm showing right now is actually demo data, but this is actually real software talking to essentially mocked up servers. So this, what I'm showing you is actually the Pulse that was essentially deployed or activated previously. So here we see, in this case, we have 4 or 3 mocked up data sources, Contra Costa, John Muir, and San Ramon Medical Center. So now I'm going to go ahead and do a query, and this again is a live query. I'm actually going to search for John Doe, who does not exist, just to show you this is live. So select male, female, 1, and hit search. No results. Now go back and repeat the search for someone who actually is in here, Jane Doe, and female, January 16th, 1988. And there we go. So this is, again, live query, real software against mock-up servers. Here we see a summary of what was found. For those endpoints found through the FHIR-based healthcare directory, we see that these actually had responses. We see that 2 documents are available from the first source, 1, and so on. We also can see information about the patient. Oftentimes, of course, they may present with ambiguous demographic information, so you need to make sure it's the right person, so you can pull this up and do demographic confirmation to disambiguate the patient. Once you're satisfied you have the right person, you can then click on that button, and then this shows a summary of all of the documents available through the live real-time query. Here I'll actually click on physical test. And now this document was retrieved live in real time. So here we see a CDA document. In the future, I think this will probably be a FHIR resource puller as well too. And then you see this is actually pretty rich. It has provenance information, authenticators, care team, has allergy information, encounters information, immunizations, med history, current problems, procedures, results, lab results, social history, and so on. And there's more information available as well too. And then once we're complete, if we want, we can actually log out and get back to where we started. That's it. I think we have about 1 minute left for any comments or questions. Otherwise, thank you very much.